But some more vocab. We're still going to stick with angles. You know about an angle bisector already. Now we're going to get to a little bit more what happens if I start putting a couple angles together. First vocab term today, adjacent angles. Adjacent, usually you think adjacent probably next to. Yeah, kind of. Here's the three things you need to have adjacent for two angles to be adjacent. And they're written in the definition, but it's hard to pick them out. First thing it's got to have, common vertex. If two angles are going to be adjacent, they both have to have the same vertex, common vertex. Second thing it has to have, it's got to have a common side. It's got to share a side, common side. All right, that's not going to get in the way. And third thing, and I'll explain this as we go through our three examples up here of yes or no, it has to have no interior points in common. I'll tell you what that means here in a sec as we're doing this. So those are the three things it has to have for two angles to be adjacent. All right, this isn't a multiple choice question. This is yes or no, are they adjacent or not? So let's look at A right now. Everyone see angles X and Y. I put them inside for you. Do they have a common vertex? Yes. Do they have a common side? Yes. We're all in agreement so far. So here's what I mean by no interior points in common. Everyone, please put a point inside angle X. Right, just put a random point inside, not on it, inside angle X. Is that point also in angle Y? No. Put another point inside angle X. Is that point inside angle Y? Is there any point you can put inside one of these two angles where it's in both? No. That's what this means. No interior points in common with each other. So it shared a vertex, it shared a common side, didn't have any interior points. Hey, X and Y are adjacent. We don't have to write an explanation. I just want to say adjacent or not. What about B? Common vertex? No. Okay, stop the discussion then. I don't care if it has the other two. No common vertex, not adjacent. All right, C, just so we're clear before we say yes or no. Angle Y, everybody, is this one right here. All good? Angle X is referring to the entire angle here. All good? Everyone see angle Y, this one, angle X, the full one. So do they share a common vertex? Yes. Do they share a common side? Yes. Yeah, it's this one right here. Can you put a point in one of the angles that's in both? Yes. Yeah, I can. Right here. That's in Y and it's in X. So yes, yes, no, sorry, they're not adjacent. Has to fulfill all three requirements. 2 out of 3 won't cut it. All right, so there's adjacent. You guys heard of the next term before? Complementary. All right, one thing oh boy, especially in this level of geometry now. It's got to be 2. If I give you 3 angles that add to 90, you know what that's called? 3 angles that add to 90. Okay? It's got to be 2. Got to be 2 angles that add to 90. Now, let me give you probably your elementary school version of this example. Oh, this angle's 50 degrees. This angle's 40 degrees. They are complementary. High school level example. Ready? Complementary. How do I know they add to 90, by the way? Or am I just good at this? Too good at this. How do I know they add to 90 here? What do you got for me, Will?
It's a right angle.
It's a right angle, equals 90. Yep. And those two added up, give me that 90. Also, 1 and 2 are complementary. They're also adjacent. Correct. We're going to start using some vocab around here now. 1 and 2 are complementary. They're also adjacent. And then you have on the other side, supplementary, 2 angles that add to 180. Again, hey, 2. It can't be more than 2. If you're going to say angles are supplementary, you're telling me there's 2 angles there. All right, elementary school version, ready? Example. Here you go, 120. 60. There's your elementary school example. Here's where we need to be at. Supplementary. Everyone see what? How do I know they add up to 180? They put together, they form a line, straight angle, which we know from Wednesday equals 180. 1 and 2 are also adjacent. Nice, adjacent. All right, so here's what we're going to do right now, especially with the supplementary example. If I ever give you two angles that are adjacent and supplementary, we're going to stop saying adjacent and supplementary and just give it one term only. Linear pairs. Okay, linear pairs. If two angles are adjacent to each other and add up to 90, let's not say adjacent and add up to 90 anymore. Let's say linear pairs. Okay, let's start saying linear pairs. Plus the word linear has what word in it? Line. A pair of angles that form a line. You think A is a linear pair? What's wrong with it? Well, okay, but do 1 and 2 form a line? Are they supplementary? No, so these are not linear pairs, but they are what? They are adjacent, yeah. The problem is they don't form a linear pair. How about diagram B? Yep. That's a linear pair. And how about C? No. They're not even adjacent, right? So how about these vocabulary terms? Complementary, supplementary, and now linear pairs. All right. Welcome to your first theorem here in geometry this year. This will probably be the first of about 75, not the scary, for the entire year. When you see the word theorem, just think of the word fact for me. Here's a geometry fact I'm going to throw at you. All right. Anytime you know you have linear pairs, here's the first fact, and we kind of mentioned this already. Linear pairs are blank. And this is something I can always use, something I can use. So yes, I know they're adjacent. I don't really need, that's not going to help me too much. What's the other fact we know about them? That linear pairs are, they add to 180. Big boy, big girl word for that is supplementary. There you go. There's your first theorem. Fact. Geometry fact. Okay, linear pairs are supplementary. Oh, that's a linear pair? Add them up, set them equal to 180. Anything. So I feel like I'm going pretty fast here, but it is honors. All right. I don't think many of you heard of the next term, vertical angles. Vertical. Hey, take a look. I have two lines that intersect right here. Two lines that intersect. How many angles did I just form? 4, right? The opposite ones are vertical. Okay. Two lines intersect. You form 4 angles. The opposite ones are vertical. Okay. The opposite ones are vertical angles. Those are referred to as vertical angles. So look at my diagram. Do you think A would be classified angles 1 and 2 as vertical? No, but they are. Okay, yeah, everything I'm hearing is right. But now we can put adjacent and supplementary into what? The linear pairs. Let's start talking like that. All right, so not vertical, but they are linear pairs, correct. How about B? They have to be formed by 2 intersecting lines. Lines measure 180, and they certainly don't measure 180. Not vertical. And on number C, letter C, somebody made this point in my last, how do I know those are lines? I'll tell you, they're lines. So 1 and 2 vertical? Yep. All right. Fact number 2, they come pretty quick. What do I know about vertical angles? Help me right now. Help me. Okay. That angle's 50. You don't need to, just help me out. You may not be confident enough, but you can find the other 3 right now. You can find the other 3 angles pretty quickly. If that's 50, what's the one right next to it here?
40.
They add to 90? They add to 180, right? So this would be 130 because they're linear pairs. Keep going. This would be
50.
This would be okay. What did we just find out about vertical angles? They are congruent. Yes, I don't want to hear equal. They are equal, but We got a better word now. Vertical angles. I'm going to start doing my shorthand here. Vertical angles are congruent. Sidetrack for a quick second here. I'm never gonna take off for spelling. All right, never take off for your spelling, but have a little self-respect. Okay, here's what I mean. Vertical. Notice the 3 letters at the end. C-A-L, not C-L-E like the word barnacle. Okay, have a little self-respect when you spell. Will I ever take off? No, but I may write you a little note that says, you're embarrassing your community, your family. Have some self-respect. Okay, vertical angles are congruent. Good. All right. What about these? What about this term? Perpendicular? No? Okay, that's fine. Perpendicular, 2 lines that form right angles. So give me line AB and give me line CD that look like they form 90-degree angles. What should I put on my diagram that there's a 90-degree angle? Because I don't write 90 anymore. Yep, so I need the symbol here. Oh, 2 lines, they form a right angle. They are perpendicular to each other. Perpendicular, 2 angles that form a 2 lines that form a 90-degree angle. How do I write this mathematically? You guys know how to write line AB? I hope so at this point in the year. Leave a little space. You know how to write line CD. Only thing I need to teach you now is what's the perpendicular symbol? Anybody know? Seen it before?
Vertical line with the horizontal line at the bottom.
So an upside down
T.
T. Yep. There you go. Ready? That's the symbol we use for perpendicular when we write. Okay, symbol for perpendicular. Questions? Okay, you have the next 6 questions on your own. We're going to do 7 as a group, but I want the next 6 questions with your partner, somebody around you, by yourself, whatever floats your boat. But go ahead. About 2 minutes, 3 minutes.
So we got EBF here. EBF is going to be
51 degrees, good start. If anybody has a question at the end, please ask where I got these angles from. Angle EBA, EBA. Here we go, 27. 90 degrees because it's adjacent next to linear pair with the other 90. 1, angle DBE. 17. How about angle DBC? 7. Buck 7. Good work. ABF. 27. Buck 41. And finally DBF. 21. 68. Anybody want to go over any of these? See where the numbers came from before we hit some word problems up. Ooh, our favorite. All right. Word problem time. 2 angles are complementary. Let's stop there. That means they have to be equal to what? 90. 90. That's our first thing. Not 180, 90. So you don't have to do it this way, but hey, angle 1, angle 2 have to add to 90 degrees. Boom. They have to add to 90. Now it's a matter of what do I fill in there? Okay. How do you write these 2 angles? Well, one angle, the smaller one, is 50 less than the larger. I don't require this, but it helps me stay organized and probably help a lot of you stay organized. Writing let statements. And I'll show you why I love them at the end of the problem when we have a solution. So I always let X equal one of the angles. It's just a matter of, in this case, is it going to be the smaller or the bigger? There's no wrong answer, but I do want to make a class decision here.
bigger.
Bigger. All right, let's go bigger. So if X is my larger angle, so X, the degree of the smaller is 50 less than that larger. How do I write 50 less than that then? 50 less than that. 1. 50 less than that angle x. What's less than? What operation? You get the minus, right? All right, so I'm going to do x minus 50. Okay. Now, some people chimed in, hey, let's let x be the smaller. Fine. But you're not writing x minus 50 as the larger. You're going to write x minus or x plus 50 as the larger. That's fine. You're not wrong if you called x the smaller. All right, now we solve it. There are my two angles, x and x minus 50. Let's solve it. 2x minus 50 equals 90. Move the 50 over. 2x equals $1.40. X equals. All right, now this is why I like let statements. If you don't write a let statement, do you know which angle this represents? Maybe not though. But to me, I let x equal what? So that answers my larger. What's the question asking for? Oh no, what's it asking for? What am I? The larger. Find the degree of the larger. So I know I'm done, and I don't have to plug it back in. Because I called x the larger, I'm good. All right, that's why I like the let statements, to figure out if x is what they're looking for or not. Questions? All right, one more I'm going to do with you. All right, this is definitely something brand new to you, so I'm going to slow it down. Okay, two angles are supplementary. They're going to add to $1.80, so similar to what I just did here. They're going to add to 180. Ooh, but now a little something different. They're in a ratio of 7 to 2. What are those two angles? Well, first, let's talk about what it means to be in a ratio of 7 to 2. That could mean one angle is 7 degrees and the other angle is 2 degrees. But would that make any sense in this problem? Why not? Has to equal 180. All right, well, I could also double these numbers and get 14 and 4. 14 and 4 are in a ratio of 7 to 2, but does that make sense? No, why not? Got to add to 180. I could triple them. 21 and 6 are in a ratio of 7 to 2. Does that make sense? All right, I'm getting fed up. I'm getting annoyed. I'm not doing this guess and check thing until I hit the numbers that add to 180. I'm not going to multiply by 4 or 5. But I got to figure out what number I need to multiply by, though, right? That when I add them together, give me 180. What is that number I need to multiply by? 7 times what? Right? Plus, what's the other number in the ratio? 2 times that same number. See what I'm doing here? I'm figuring out the number I need to multiply 7 and 2 by so I can add them and get $1.80 instead of guessing and checking. Okay? So anytime I have numbers in a ratio, you're going to always see me put the same variable with them. Does that make sense? The 7 to 2. Question? Everyone ready to solve? 9x equals 180. X equals 20. Does that mean one of my angles is 20 degrees? No. That means I need to plug it back in and multiply the 7 and 2 by 20 to make sure I figure out what my degree measures are. 20 is not an angle measure, but it is the number I need to multiply by. All right, so what's one angle? 7 times 20 at 140. Other angle, and I don't care how you label it here. Other angle, 2 times 20, 40. And how can I check this very quickly that I got the correct answers? They should add to. They should be supplementary, which they are. Question now?
Yeah, would that work for all of them? Like, where you can just add?
3 to 4. 3x, 4x.
Well, I was going to say, for all the ratios you get, can you just add the two numbers in the ratio together and then see how many times they go into what you want to
That's, yep. Mm-hmm. For this type of problem, anyway.
Okay.
Jack, really. You're good. Sure. Right now? Yep, no problem. Yep, bye-bye. Max Cleary. Got head down, all done for the day. Okay. All done for the day, they tell me. All right, down to the main office. Have a good weekend, behave. All good. All right, you're on to the last problem for the day on your own. Okay, hey, directions. Directions. Let's see what you got.
So, A and E, ABC are supplementary and they are adjacent.
Okay, let's talk now. Let's talk. Here we go. It told you EBC was 40. It told you the other two were congruent to each other. Let me know what you got and how you got there. I don't need an equation. I don't need anything fancy. I need you to talk to me about how you got it. All right, I need you to talk to me about how you got your final answer. All right, let's roll here. 14, talk to me. What did we get?
I got 70.
Okay, well, we're on that's the first step, right? 70 degrees. How'd you get there?
I made an equation.
Okay, I'll hear the equation. What is it?
I did 2x because ABD and DBE are congruent.
Yep.
And then I did plus 40 for EBC, and then I made it equals to 180.
Good. Okay, you could set up an equation. I don't need an equation, though. But hey, I need to know what you're thinking, though. If you just wrote down 70, that's not going to fly in here. I need to know what's going through your head because let's be honest here. Some of you may just have good eyesight. Catch my drift there? Good eyesight? All right, you're just peeking over around you and just getting the answer. All right, got it. All right. Good eyesight. Yeah, I know what he's talking about now. All right, got to show me what you're doing here. Got to show me. All right, even if it's this, hey, 180 minus 40, 140, cut it in half. Fine, but I need something. It doesn't have to be an official equation, but I need something written down that shows me, hey, this is how I know it's 70. All right, questions? Homework's at the bottom of the page like usual. You know the deal. Compass and straight edge to class on Monday. Wednesday, and I will be here after school on Tuesday. Wednesday, unit test.